In this video, we're going to apply a /30 subnet mask to an ipv4 address and identify what happens to the size of the subnet. We were using the same addresses we've been using, 192.168.100.10. You should have a pretty good idea what's happening. When we did a /24, we had a total of 256 addresses. When we did a /25, we had a total of 128 addresses. When we did a /26, we had 64. When we had a /27, we had 32 addresses. A /28 garnered 16. /29, we just did that one. That was down to 8. /30, you know this is going to end up at 4 addresses. 4 addresses. Now take a look at the bit pattern of 10. In any given network, in order to be in the same network as the number 10, the bit pattern in the 4th octet has got to start with 4 zeros, a 1, and a 0. It's got to look like that. It's got to start that way. If it doesn't start like that, it can't be in the same network because it's a /30. We've got 8, and we've got 8, and we've got 8, and that's 24, and 25, 26, 27, 28, 29, and 30. 30th bit is right there. 30th bit says, hey, these have got to be exactly the same to be in the same network. So we're left with just 2 digits left to create our networks with. So we have 2 host digits, and we have 6 digits in the 4th octet for network. So I'm going to write out those 6 digits for the network first in red, and then I'll write out the combination that we need for this particular system for the host portion. So let me go ahead and make a change to the pen here. Make a change to the pen. There we go. And we're going to say the bit pattern for this particular network has to start like this. The 25th, 26th, 27th, 28th, 29th, and 30th digits are listed right there. And that's the pattern that we have to be in if we want to be in the same network as the number 10, right? Now, host-wise, we can start with 2 zeros and we can end with 2 ones, and that's going to give us our range of addresses that 10 happens to fall into. So if we add this up, we get 8. And if we add this up, we get 8 plus 2 plus 1, which is 11. So our network ID with a /30 for this particular address, our network ID is going to be 192.168.100.8. And our broadcast ID is going to be 192.168.100.11. And that's the subnet that we happen to fall into because our bit pattern happens to be 10 there. If it was 2 zeros, it would be an 8. If it was 2 ones, it would be an 11. So it happens to be 10. It's 8 plus 2, that equals 10. 8 plus 1 would happen to be 0, 1. That would be 9. That's the whole size of the network. So there's 2 usable addresses on the /30, and there's 4 total addresses on the /30, and that's all there is to it. So other sizes of networks or other networks that we could come up with, if our bit pattern was all zeros, we'd end up with a network that would be 0 through 3. If we had a 1, there would be 4 through 7, 8 through 11, 12 to 15, so on and so forth, creating networks that are only 4 total addresses inside with 2 usable addresses. You'll see these in a lot of what are called point-to-point networks, where you have a router connected into another router, and they can only send stuff back and forth to each other. But you only need two good addresses, one here and one here. These will very often be /30s. So keep that in mind. We'll put another video out with more subnetting, but this takes us through the whole 4th octet subnetting off of the dot all the way from /24 all the way through /30.